Want to know the ultimate secret tricks of the master builders? Today, we'll learn to use magic skeletons, recycle parts, and build lazy robots. Building complex software from scratch is like trying to carve every tiny gear and screw for a clock by hand. It takes a massive amount of time, and trying to get every tiny piece to fit perfectly is exhausting. To solve this, developers use an application framework. Think of it as a pre-built, reusable program skeleton. It provides the heavy structural support for you, so you don't have to invent the basic shape of your project every single time. By starting with this sturdy frame, you skip the repetitive foundational work. You get to jump straight into the parts of the project that make it unique and special. At the center is a strong pillar called a microkernel. It's the indestructible heart of the framework. If you look at the joints, you'll see pre-made empty slots. They let you add new parts later without breaking the core. The name for these special snap-in slots is Callback Interfaces. Think of them as open ears, waiting for you to tell the robot what to do when a specific joint moves. When you write your own code, you are simply snapping your custom instructions into these ready-made slots. This system is powerful because it lets you add your own creative ideas onto a structure that is already guaranteed to stand up straight and work correctly. To make these pieces work efficiently, we follow Creational Design Patterns, which are essentially proven blueprints for how to build things inside a program. The first blueprint is called the object pool. Usually, making a brand new part for a toy, like an arm or a leg, takes a lot of computer energy. If you have to make 1,000 new parts every second, the whole system starts to slow down and get tired. Instead of wasting that energy, we simply borrow a part from a shared bin, the object pool, that another toy is finished using. This recycling system keeps the computer from getting exhausted. It runs faster because it's reusing high-quality parts rather than building them from scratch over and over. Moving to a different corner of the workshop, we find a rule called lazy initialization. This delays the creation of an object until the absolute last possible moment it's needed. This robot refuses to wake up or use battery power until given a specific chore it can no longer avoid. Being lazy like this actually makes a program much more efficient. It doesn't waste memory on things that aren't being used, keeping the whole system light and snappy. Inside this glass booth, we use the prototype pattern. Sometimes building a part is so complicated that it's easier to just copy a finished version rather than following the assembly instructions all over again. Think of it as a magical cloning machine. Put in one perfect toy, and you instantly get an exact copy without assembling a single gear. This is a major shortcut for builders. It allows them to duplicate their most complex work instantly, saving them from rebuilding it from the ground up. Finally, let's look at this tiny model town to understand the utility pattern. In technical terms, this is a class with a private constructor that contains only static methods. But it's much easier to understand if we look at the town square. The private constructor is like a heavy community toolbox bolted to the floor. No single person is allowed to take it home for themselves. But the static methods mean that everyone in town can walk up and use the shared tools inside, like a communal hammer or wrench, whenever they need them. This creates a shared space for common tools, so that every individual part of your program doesn't have to waste time making its own personal set of equipment. We've explored quite a collection today: the sturdy skeleton, the recycling bin of parts, the sleepy robot, the cloning machine, and the shared town toolbox. You've now learned the foundational vocabulary used by professional developers to build clean, organized software. Next time, we will decode secret spy languages and play with chameleon toys when we explore advanced behavioral design patterns. Thank you for watching. Understanding how to build and organize these pieces is what helps us create programs that stay strong and manageable as they grow larger and more complex.